In order to scan large architectural structures such as the Bayon temple, we have to use different types of sensors depending on the location of objects in the site. To scan the deity faces of Bayon, we used a long-range laser sensor named Cyrax. We measured each face from many positions such as the ground, a scaffold on the roof, and a bucket lifted up by a crane. The data from different directions were integrated, and a 3D digital model of each face was built. To scan the fine reliefs carved both on the wall surrounding the temple and on the wall inside the small rooms, we used a short-range laser sensor named Vivid. As for the wide area of the wall, we measured this iteratively by shifting a sensor mounted on a small crane little by little. Many valuable reliefs are left on the pediment of the tower surrounding the terrace. However, they could not be scanned from the front side because they are hidden behind the architecture itself. Thus, the upper part of the reliefs were measured from the terrace, while the lower parts of the relief were measured from the ground by using a special sensor that utilizes a mirror. Data from both sources were integrated, and complete 3D digital models of the reliefs were built. To scan the open space around the corridor and the whole structure inside the towers, an omnidirectional laser sensor named Z+F imager was used. With this sensor, the entire structure of the temple, including the corridor, was measured by a small number of scans. To scan the narrow space between the terrace and the corridor, a laser sensor named Climbing Sensor, which moves vertically along a ladder, had been developed and was used. Bayon Temple is a huge architectural structure with a large number of high towers, and it is not practical to scan the upper side, especially the roofs, from scaffolds. For this task, we used a balloon sensor, a laser sensor suspended under a balloon which had been developed for this purpose. Two different types of laser sensors were alternatively equipped, depending on the distance to the target. The balloon was manually controlled by 4 ropes pulled from the ground. To minimize the effect of drift of the balloon, only a small amount of data was obtained in each scan. Thus, the sensor scanned the same place multiple times, and all the data were integrated later so as to build a dense 3D digital model. By scanning from the air, we could obtain the 3D digital model of the upper side of the Bayon temple, which would not have been possible from the ground.